Okay, because we're working today in section 8.4, which is on perpendicular vectors. Like, how do you really figure out if something is a perpendicular vector or not? And what we're going to be getting into is cross products and dot products. We're going to start with what's called a dot product and then move on to a cross product. Later on, you can see that you actually use cross products in torque, and it has to do with like a torque equation. But we're actually not going to get into that. We're not going to get into the application. We're going to really stick to just the math of this. How do you do the math part of this cross product and this dot product? And then hopefully you can get into the physics of it, the science of it in a physics course. Sorry about that noise. All right. So we're going to stick to just the math. So hopefully today we'll get through knowing the dot product, the cross product, and when something's perpendicular. So we're going to start with this inner product, or it's called dot product, also known as the scalar product, because the answer is a scalar. It's a single value. The rule is, for perpendiculars, if the dot product is 0, then the vectors that you are taking the dot product of must have been perpendicular. All right, so it's kind of like a test to see is it perpendicular or not. Dot product really follows well after doing addition and subtraction and scalar multiplication of vectors. It's very similar. It's a lot like what you might think when you're multiplying two vectors together. So this p dot q, p is 2, -1, and we're taking the dot product with q. Q is 714. And what you do is actually just you multiply corresponding parts. You're going to multiply the x's together, the 2 and the 17, and we're going to multiply the y's together, the -1 and the 14. And then to find this product, you just add those values, add what you get. So 2 times, I don't know where I got the 17, I apologize guys, it was 2 times 7. 2 times 7 is 14. 1 times -14 is -14, so that is a 0, okay? And the answer here was, are any of them perpendicular? Well, when the answer is 0, the answer is yes, they are perpendicular. It is perpendicular, okay? Now we're moving down here a little bit to the next project, or the next question is P times M. So let's write down P and M. P is 714. M is 3, 5. Corresponding parts, we're going to take 7 times 3, and then we're going to take, add that to, 14 times 5. Okay. 7 times 3 is 21. 14 times 5, I believe it's 90. I got to go check that out on my calculator really quick. 70, excuse me. So my answer in the end is 91. Well, 91 means nope, they're not perpendicular. Only if it was equal to 0 would it be perpendicular. There's only that one option. So let's do our last problem here. Q times M. Q is 2, -1. M, sorry about that, 3, 5. And then what we have to do is we're just going to take the 2 times the 3, and we're adding it to the -1 times the 5. 2 times 3 is 6. And we're going to add it to -1 times 5, -5. Answer is no. Is 1. So that means no, not perpendicular. I'm moving ahead of myself as far as my thinking and my talking. This also works when you have a three-dimensional figure. So when we have 3 values, it's very similar. So when we're going to take the dot product or the inner product of V and W, what we're doing is we're just taking the 2 times the 8, the x's times each other, we're adding that to the -3 times the 3, the y's times each other, and we're adding that to -4 times 2, the z's times each other. So we have here 16 plus -9 plus -8, okay? The -9 and the -8 together is -17, and the positive 16, it turns out to be -1. So the answer here, no, that one is also not perpendicular, because if it was 0, then it'd be perpendicular, anything else, and it's not perpendicular. So dot product's not so bad. Perpendicular, figuring out whether it's perpendicular or not so bad. Now we're going to get into cross product, which is just a little different. When you're looking for the cross product, you're actually, a cross product is saying I have 2 vectors, they're 3-dimensional vectors, and then their cross product is another vector, the answer is another vector that's perpendicular to both of the original vectors, okay? So what we need to do here in the process is actually you end up taking the determinant of three vectors. First of all, the unit vector, which is I, j, k. And then you take that times the first vector you're talking about and the second vector. So our first vector is here, and it's shown as a1, a2, a sub 3. Second vector is in our b vector, and it's shown as b sub 1, b sub 2, b sub 3. So really what we're doing here, we'll start with, it's like we're saying, okay, we're going to take this one, and you take your first value, your I, and you ignore the rest of the things that's in that row and in that column. So if you notice, what's left right here is A2, A3. Look how that matches here, all right? And we're going to take the determinant of that. And then what we do is we kind of move things around. I guess I'm going to get rid of that. So now what I'm doing is basically I move this circle around that I'm talking here, and I kind of do that, all right? So now the circle here, the J, is what's circled here. And what I'm left with is A1, A3, B1, B3, and that's what's here, okay? Notice here, and it's kind of our formula for when we're taking the determinant, that we have a minus, that it goes plus, minus, plus, minus, all right? And that's just the formula for taking a determinant, that we should have a positive and then a negative and then a positive here, okay? It's formula for taking determinant. So here, last one that we would find here is that we have our k, and we're multiplying that times a sub 1, a sub 2, b sub 1, b sub 2. All right. Well, the results are another vector, and the vector kind of looks like this. I think if I show you working it out, it's hopefully making a little bit more sense than what we have here. Okay. To see, oh, did the original two, were they perpendicular to each other? The answer is you have to figure that out by finding the dot product first. You can't tell anything about perpendicular using the cross product other than you know that the answer is perpendicular to the two vectors that you started with. Okay, so let's look at this. We're looking here, and what you want to do to start with, so what we do is we start by drawing our vectors, and vectors are this I, this j, and this k, and I just write out I, j, k. And then we write the next vector, our v vector would be a negative, v, negative 4, 1, 0, and the w vector is 5, 4, negative 2. Okay, and we're trying to find the determinant of this vector. So to find the determinant, the process is you take the upper right and we kind of ignore everything in that row and in that column. So we're going to take the determinant of 1, 0, 4, negative 2. And then we're going to multiply it by our I there. Okay? Then we kind of move this over, if you remember what we do here. I'm going to kind of keep that going over there. And so now we're going to, and it's the opposite sign now, so it's subtraction. We're going to take the determinant now of 4, 0, 5, negative 2. And we're going to multiply it by, not our k, excuse me, our j. All right, our j value that's there. And so we write the j in there. Okay? And then we're going to have one last determinant. It's going to be multiplied by the k. I need to move this over, move everything over here kind of thing. All right. And then what I have left is negative 4, 1, 5, 4. And if you remember, when you have a 2 by 2, the determinants are actually found by taking the down diagonal minus the up diagonal when you multiply them. So we actually need to take 1 times negative 2, and we're going to subtract 4 times 0. 1 times negative 2 is negative 2, minus 4 times 0 is 0, so our answer here is negative 2. And we still have our I there, okay? Here, it would be negative 4 times negative 2, and then we're subtracting 5 times 0. So really we have 8 minus 0. So 8 minus 0 is 8. So then it's minus 8j. Here it's negative 4 times positive 4 minus 5 times 1. So it's negative 16 minus 5. Negative 16 minus 5 turns out to be negative 21. So it's like plus a negative 21k. Now that one you can leave as your answer. If you want to give your answer as a vector, that's like a unit vector. If you want to give it in a full vector, all you do is you get rid of the I, J, and the K, and you change it with separate it with parentheses instead. So it could be 2, -8, and -21 is your vector there. So you can get rid of your unit part of your vector by saying it's the same thing. I don't really care which way you're going to show your answer. Both of them would be fine. Let me do another one here. I'm going to go ahead and copy this. I'm going to do it on the next page here. So let me do one more just to show you another example of what that looks like here. So here's my vector that I'm trying to find. If you remember, I'm going to set it up here. I'm going to pause it, set it up, and I'll. Okay, so we have it set up here. All right. So if you remember, what we're doing is we're going to kind of, isolate here. And we kind of go through and we isolate different values here. So we're going to start with, we're taking the determinant of -3, -7, 5, and 8, and we're multiplying it by the I vector. And then we're subtracting, and in our heads we're moving this over here. Okay, and then we're subtracting 2, -7, 3, 8 multiplied by our J vector. And then we're adding, again, we're kind of moving this over here. All right, adding 2, -3, 3, 5 times our K vector. So now we have to take the determinant of each of these. -3 times 8, so I'm kind of doing this. I'm multiplying this way. I mean, I should use another color here. I'm multiplying down this way and then up this way. So I'm saying here, -24 plus -35. So when I get the determinant of that, I get -59. And I still have my I. Here I'm going down and up this way, so it's 16 and -21. So there I'd get minus a -5 times my J. And then here I'd have 10 and a -9, so it'd be plus 1K. All right. Here I might write that as plus a positive just because we had minus a negative. If I wanted to write it as a vector, I just ignore my units and I put parentheses in between everything. So that's the vector. So your answer could be this unit vector or this vector without the unit vector. They're really representing the same thing. The assignment I want you to work on for this is on page 509, problems 11 through 19 and 21 through 22. So it'd be okay if we just stop here and we just do a couple of the cross products that were a little bit more difficult. Good luck.